video focused on a new property you're going to learn. It's the inverse properties of logarithms and exponentials. All right, so here are the two properties in the blue. Let's start with the top property in the box, the inverse property of a logarithm. So if you have a logarithm of some base and then an exponential of the same base, what happens is they cancel each other out, and you're just left with whatever that power is as your final answer, and it doesn't become a power anymore. So I have two examples here in the red. Talk about the first one. I have a logarithm base 3, an exponential base 3. So what my final answer will be is just that power, which now becomes a single y. All right? Next example, logarithm base 5, exponential base 5. So my final answer is 4. All right, let's head down to the second property. It's when we have an exponential base raised to a logarithm of the same base. What happens is you're left with whatever this is, x. All right, so let's do a couple examples here. You have an exponential base 5, a logarithm base 5, but your final answer is just y. Second example, an exponential base 3, a logarithm base 3, then your final answer is 4. These properties are called your inverse properties. So when we refer to it later on in our problems throughout this chapter, these are the inverse properties. So now let's do a couple more examples and how we can do that. So I'm going to show you the way you've already learned, two ways to simplify this expression. So here is the first way. To simplify this expression, so I have a logarithm base 2 of 8 equals some number. So I'm going to just go ahead and throw an x. I want to find out what x is. So the way that you were taught before is you could take 2 and then you could raise it to the x power equals 8. So what we're doing is the process of rewriting to exponential form. So we're converting it out of a log form and into an exponential. Now, can we use the one-to-one property next? So I say 2 raised to what power equals, and now we're going to rewrite that 8 as the same base, 2 raised to the third. Now we can apply the one-to-one property. The one-to-one property says if these equal each other, then the powers must equal each other. So this is the one-to-one property. X equals 3. Now I'm going to show you the second way by using an inverse property. The logarithm, so we're going to take the second way. And we're going to use the inverse property to simplify it. So we have that logarithm base 2 of 8 equals some number. What I'm going to do is I'm going to go ahead and throw an x at the end. All right, so I'm going to say logarithm base 2, and now think about 8 is the same thing as 2 times 2 times 2, or 2 raised to the third power. Now if you remember from the inverse property, you have a logarithm base 2, an exponential base 2, so your final answer is whatever that power is. So x equals 3. Notice you get the same answer, just a different way. All right, last slide in this video, we want to simplify some of these expressions. All right, so the first logarithm, an exponential, is an inverse property. You have an exponential base 3, a logarithm base 3. What happens is you get the number 6. All right, now we have this logarithm. It's not inverses yet, but let's think about 25. Can we rewrite 25 as an exponential of the same base? Yes. 5 times 5 is 25. So now we can use the inverse property again and say we have a logarithm base 5, an exponential base base 5, so that whole thing becomes a 2. So now we can simplify these two numbers. 6 plus 2, what does it equal? 8. So this whole expression up here simplifies down to the value of 8. All right, let's do example C. Pretty similar to the last one. We have a logarithm base 2 of 32. Let's use our inverse property. So think about, how can I rewrite 32 to have a base of 2 raised to some power? Well, 2 raised to the 5th, so 2 times 2 times 2 times 2 times 2 is 32. So what happens there? I have an exponential base 2, a logarithm base 2, and an exponential base 2. Bam, there's our 5, using our inverse property. This is going to go a little quicker. We already have it set up. We have an exponential base 5, a logarithm base 5. So that final answer there is going to be 3. And we can't forget about that minus. So 5 minus 3 equals 2. And that's how you can use your inverse properties to simplify expressions.